Hi, this is a tour of my solar power system, and my goal was to be able to run the electronics in my house, the computers, modems, printers, television, and also be able to charge different types of batteries, AGM, gel batteries, flooded batteries, different size batteries, different age batteries. So let's start up on top of the roof. I have 5 solar panels up there, 100-watt panels, 3 of which are connected in parallel, and they come down through number 10 wires to a 30 amp fuse disconnect to a 30 amp PWM charge controller, and that's charging a 100 amp hour AGM battery. Back up on the roof, I have 2 more solar panels in parallel. They come down through a fuse disconnect to another charge controller. You might not see it over here, and those feed an auxiliary batteries on the outside through these this chassis mounted PowerPoint connector here. These batteries here are just plugged in. These are all plugged in. I can take these out to the field with me, remove those. I can plug in an old car battery here to charge it if I need to. The negatives on all these are common. The positives go through switches and come back through a fuse. These happen to be 80 amp fuses, and then they go into this diode array. These are Schottky diodes. These are 220 packages. Each package has 2 diodes in there. Each diode is good for 15 amps, so I have 60 amps top and bottom. This is the anode of the diode. This is the cathode, and it goes to the inverter. These Schottky diodes have a forward voltage drop of 0.3 volts. That means if there's 10 amps going through here, I'm going to dissipate 3 watts across there, and these don't even get warm here. From there I go into my inverter, pure sine wave inverter. I calculated I needed about 500 watts, so I doubled that. I got a 1,000-watt inverter. It was only a $150 inverter. From there I come out with some number 12 wires through a ferrite core, and then into a Emi filter. This is a 2-stage filter. Clean up the power a little bit, and then I go through a 8 amp fuse, and then from there it goes back into the house through a 1/2 inch EMT conduit. I have 3 plugs in the house, one for the TV, one where the modem's located, and one where the computer's located. Most questions I get is how much did it cost, and when will I get my money back? I have about $1,400 in here, and it'll take about 8 years to get the money back, but before that happens, I'm going to probably have to replace the batteries. I might go with MPPT charge controllers. The inverter's probably not going to last 8 years, and so I might not get my money back for years, but I had fun building the thing, and it's been working for a couple months now.